As adoption of Snowpark container services has scaled, we've received feedback that the product can sometimes be difficult to manage, monitor, and troubleshoot. That's why today I'm excited to announce the general availability of a set of complementary journeys for developers and admins in Snowsight that give you the manageability you need to deploy SPCS at scale. What that means for admins is a set of experiences around managing compute pools or dealing with image repositories, as well as a set of developer-facing features that let you, for example, create a service or execute a job from an existing image, debug a service using application logs, diagnose containers that may be out of memory or crashing using platform events, as well as the ability to benchmark resource-hungry workloads, for example, ML workloads that use GPUs, using platform metrics. Let's take a look. Compute pools are the units of governance for the underlying infrastructure where containers run in Snowflake. And we have an experience in Snowsight right under Manage Compute pools that lets you visualize all the compute pools in the account. And this is super handy because you can obviously see the instance family or what kind of hardware is being used by the compute pool, its status, number of services that are using it, but also the number of nodes and specifically how many active or idle nodes there are. And this is great for cost control, as well as the last time the compute pool was used. In this case, let's dive into a compute pool that I use in this account here. And what you'll see inside is the list of services that are using that compute pool. And some of them are in suspended state, and we can see that we have one running service. And this is great because I can now very easily find out what's using a certain compute pool. One interesting thing here is that if we want to find the specific type of service, so for example, the service backing a notebook or the service backing an inference endpoint, I can now filter for that in this list here. And so, for example, I can easily drill down to the exact workload that is causing usage in the compute pool. In this case, I can see that I have one notebook managed service in the compute pool. What we also see here is some additional details, so the minimum, maximum, and number of active nodes, as well as the privileges in that compute pool, which roles are allowed to do what kind of actions. We can edit the compute pool. So for example, one common scenario would be increasing the number of node limit if users have reported that their services cannot be scheduled. We can tweak some of these more advanced settings, for example, the resumption and suspension behavior. We can also obviously suspend the compute pool, drop it, or transfer the ownership to a different role. And then down here, we can grant privileges to a new role. Let's say customers contact us and say, I'm not able to use the compute pool. We can find their role and then give them the right privilege to be able to use the compute pool. Another new addition here is the Events tab, which lets you know of the infrastructure events that are affecting this compute pool. So for example, if I want to find out whether this compute pool has been down for maintenance in the last month, I can go ahead and select the date range here. And there you go. I can now see that between the 19th and the 23rd of May, this compute pool underwent maintenance and certain nodes may have been brought down during a maintenance window, of course. And so this is great information for an admin in case some downtime was reported during those maintenance windows. So this is an awesome and very useful view. And over time, we'll continue to add even more events here to let you know what's going on with your compute pool. But now let's move over to the next area, which is managing image repositories. If I head over to Horizon Catalog and select the Database Explorer, you'll notice that within my database schemas, I can now see any image repositories that are created there. And repositories are schema level objects, so it makes sense that they appear here. If I select the repository, you'll notice this new view we're adding, which lists all the images with useful information such as the tag and the digest. And one thing that I find particularly helpful is the ability to actually copy the full URL of that image in the repository, which is super handy if you're actually handcrafting your SPCS specification file and you need a quick link to the image itself. So this is an awesome little quality of life addition that I think a lot of you will appreciate. Now let's talk about the set of journeys aimed at making developers' lives easier. To create a service or execute a job based on an image that's already been made available in a repository somewhere in the account, you can head over to Services and Jobs under the Monitoring tab. And you can get started by hitting Create. In this case, I have an image for a simple web application based on Cortex Analyst. So I'll give it a name. I'll choose the compute pool, and you'll notice that we list all the hardware specifications of the compute pool as well as its status to make it easy to choose. So in this case, I'll choose this one. It seems appropriate for what I'm trying to do. And then I'll pick a database and a schema where I want my service to be created. We also have additional advanced settings here, the number of instances. If you need to use an external access integration to reach out to the public internet, if you're going to be using a warehouse to query data, you can specify that here, as well as the auto resume and suspension settings. But in this case, I'll just go ahead with the defaults. And then this next screen, I need to describe the container that actually has my application. So in this case, I will pick a pre-existing image here. And this is the image I want to use for my service. And in this list here, you will see all the repositories that you have access to in the account, so you can easily choose the image. And then I can go ahead and further specify my CPU requests and limits, CPU as well as memory. I can add additional containers, but in this case, we're actually okay. I do need to add an endpoint since my service exposes an endpoint. So I know I have something exposed on port 8080 over HTTP, and I'll make this available to all logged in Snowflake users. Now, sometimes you'll want to add additional capabilities that are not exposed by this UI, and for that, we actually let you drop into a YAML-based view. So in this case, I want to take advantage of the caller's rights feature. And what this will enable my service to do is to identify to the rest of Snowflake as the calling user. That's the user that logs into the web-based UI that my service makes available, instead of the service user. So with this modification, I'm now ready to create my service. I'll hit create, and that will kick off the service creation process. This screen will auto refresh, so we'll be able to see as my container gets brought up. There you go. Now it's the status is ready. As my endpoint is provisioned, this will dynamically refresh and give me all that status right in one place. Now I already have a previous version of this service pre-created, so let's use that copy to dive into logs, metrics, events, and some of the other telemetry that's coming from this service. Debugging services is obviously one of the most common tasks that developers deal with every single day. So we've made sure that as a platform, Container Services comes with rich telemetry out of the box. And now all of that is available easily in Snowsight. Let's return to the Services and Jobs view to go through these troubleshooting tools. So as you can see, this lists all the services in my account, but I can easily filter down. So in my case, let's look at the compute pool we were using earlier. And we'll see the service I just created, and then I created a copy of this earlier. So let's click into that copy. This page is a one-stop shop for the status of the service. As you saw earlier, it auto refreshes. I have my list of containers here, so I'll dynamically be able to see the status and any messages coming out of the container. We also show you how many times the container has restarted, if there was any bad exit codes, and we also give you a one-click way to get to the logs. If you scroll further down here, there's additional metadata about the service, and then we give you a few useful actions like editing the service. You can suspend it or drop it as well. In this case, we'll actually explore the endpoints that my service exposes. And so if I click on the endpoint name, I can see this pop out with all this useful information. And I can even get to the endpoint just by clicking this button and opening it in a separate window. And here's my application UI. Now, I've purposefully introduced a bug, so if I try to interact with this application, it'll throw an error. And this happens very commonly during the application development flow, and developers have to deal with this multiple times a day. So how would I go about getting to the bottom of this easily? Well, if I head back to Snowsight, I can navigate over to the Logs tab, and you'll notice that the error is front and center. So we're able to get the logs out of that container and stream them into Snowsight in close to real time. And so as you can see right down here, I can pinpoint to the exact line in my Python code that's causing this problem, and I can go ahead and address that and publish a new version of the container. Now, this is super powerful. It's close to real time, but it's limited in the amount of data we can bring back. And so you'll notice that the logs come in two flavors, live and historical. So the live logs, I think we get about 1,000 rows back at a time, close to real time. But if you want the full picture of what happened, a week ago or a month ago, you can switch over to the historical view. And it's a view of the exact same data, but this data is actually persisted and backed by your account, your account level event table. And so you'll notice that I don't just get the last few minutes, but I can go back to the last 30 minutes, even the last hour. And the other nice thing about this is that different types of logs here are tagged differently. And for example, I can separately filter standard out and standard error. So let's say I'm interested in standard error. I can easily find all the errors that happened in the last hour. This is the error we just experienced, but this is an error that happened prior. So this is incredibly powerful. We give you sort of the best of both worlds. We give you close to real-time live logs, and then historical logs that go as far back as the data that's in your event table. This view also works for jobs. So for example, if I switch to the jobs view here, we can take as an example this video processing job, and we'll dive into that in more details later in this video, but I had a failed execution, as you can see, 54 minutes ago. And if I click into that, again, I'll get the same rich information here, the failed status on the container, the message that came out. But the thing that's different is if I dive into the logs, we'll notice that the live logs are blank. And this is because when jobs complete, we lose those real-time streamed logs. And this is different from services. Services are longer running, and so generally, as long as the service is around, there will be live logs to look at. Not the same for jobs. So when jobs complete, we flush those live logs, but we do still have the historical logs, and that's where this feature is really powerful. So I can go back in here, and sure enough, more than 30 minutes ago, there were some errors, and I can go ahead and troubleshoot those in this view. So this is a quick overview of the logs feature, both as it applies to services and jobs. Now, along with the application logs you just saw, we have an additional feature which is super useful, which is platform events. And the way platform events is different from logs is that logs come from your application while the application is running inside of a healthy container. But should the container become unhealthy for some reason, let's say it's out of memory or it crashes, then you might not get application logs, and that's where these platform events are super key. So let's take a look at that. If I go back to the video job we were just looking at, we can click into the Events tab, and we'll notice the platform events that took place here in the near past. And this again is backed by the event table, and it's stored durably, so you'll have access to this going back weeks and months potentially. And as you can see, it kind of shows us what happened at the platform level. So in the beginning, we were short some nodes in the compute pool, and then provisioning happened where the underlying infrastructure was able to find a node, and this particular job requires a GPU node that's a little bit hard to find, so we're able to procure that from the CSP. So we got a node, we got started here, we ran for about 3 to 4 minutes, and then the container encountered an error. And this is great because this is coming from the underlying infrastructure and does not rely at all on the container itself being in any kind of healthy state. If we go back to the services and jobs list here, I actually have a service that I have specifically built it to basically crash and get restarted constantly. So we can go ahead and resume that service here. And this is another cool feature of the services and jobs list, is that you can resume services or suspend them straight from the UI. So I'll go ahead and get this service started. And then as it's coming up, you'll notice that it'll just sort of cycle through running and pending status the moment it starts running. So this will be another great example of the platform events, because this is not something that you're able to really observe based on the application logs. So as we can see, it's waiting to get placed on the node, and well, there you go, it's crashed. So we will try to restart it. That's what the SPCS infrastructure does. Unfortunately, this will run briefly for a moment or two and crash again. And this is where the restart count that we show here is also incredibly helpful, because you can easily identify containers that may be stuck in that state, just constantly restarting with an unhealthy exit code. And so this will be retried. We can refresh the page and see how it's doing. So it got restarted yet again. And this is a great case for looking at the platform events. So as you can see, again, we're generating sort of a steady stream of events. We tried to schedule it, it was running briefly, and then it crashed in just about a second of execution. If we refresh this again, there's a little bit of latency in receiving these logs, but we should be able to very quickly here see the subsequent repeated failure of this container. The last feature we want to cover here is the rich metrics support offered in Snowsight, which is useful when you're trying to benchmark the performance of a specific service or job. And this is especially relevant for ML workloads. So let's take a look. I'm back here at Snowsight looking at the job we were discussing earlier, and this job actually uses a large model to extract some structured data from video, and it's running on some pretty powerful hardware. This has 4 pretty substantial GPUs, and so as an ML developer, I want to make sure that I'm fully utilizing the hardware resources that this is running on. And for that, the metrics tab is key. So with a small amount of configuration, SPCS will start sending metrics about CPU utilization, memory, GPU, and GPU memory back to the event table. And with this Snowsight UI, you can now easily visualize all of those metrics. And to turn them on, all you need to do is add a line or two to your specification file. So in this case, I'm configuring the system metrics group, which includes these 4 metrics. And the information gets piped and stored durably into the event table, and I can just explore it here. So what I can see is that obviously my job is configured correctly, the tensor parallelism is set correctly, and all 4 GPUs are being utilized. I can tell that I'm not consuming all the memory on all the GPUs, so I could probably get a little bit more performance from this hardware. And obviously I am not CPU or memory bound. And so this is great information in tuning my workload. What this UI lets you do in addition is obviously set the granularity. So I'm currently set at 1 minute granularity. And then within that 1 minute, we aggregate according to average, min, or max. And so depending on what you're trying to accomplish, you can set the aggregation here that makes sense for your workload. And this just about covers the last telemetry type I wanted to show you, which is metrics. So just to recap from the set of topics we set out to cover, we started with admins and we covered the compute pool maintenance and image repository management journeys in Snowsight. Then we switched over to the developer persona. We showed how to create services or execute jobs straight from Snowsight. And then we covered 3 different troubleshooting scenarios: how to use application logs, how to use platform events, and how to use system metrics. And so that's all I have for you today, and I'm excited to see what you build with this stuff. Thank you very much.